KNN, like K nearest neighbor. So this algorithm basically work on the distance calculations, and instance based learning also. Like it will also to work out, like it is very similar to the desktop. And KNN different name. Now what is KNN? So it is very powerful. So a powerful classification algorithm used in pattern recognition means the K nearest neighbor store all available cases and classifies new cases based on similarity measure. So it work on the similarity. But how it will calculate the similarity? Uh, Based on distance functions. KNN classification approach. Obviously, if I'm talking about an object, so K new instance is classified. Like there are the two type of the data and different something like that. If new instance is come, so classify by the majority word for its neighbor classes. Now we have the green value. So I want to calculate like which is the nearby value. So the distance measure, the second example, like we have so many values are there. Suddenly, I want to test one record. So it will calculate the distance to all of them. So when I'm working with the k nearest neighbor, so it work on the distance basically. Distance measure for continuous variable. So if I'm talking about, so some distance functions are Euclidean, Manhattan, and Minkowski. The customer age, income, number of credit class, George, Rachel, Steve, Tom, Annie. And suddenly new values come like John. So I want to calculate all the distance from the George, Rachel, Steve, Tom, and Anne. Like there are the five ways are there. So distance from the George, like 35 minus 37, 35, 50, and 3, 2. So this is all the differentiation. Like again, for example, we have the noisy data. Noisy data means like we have the two type of the shape of the data. First one is blue and second one is red. But suddenly some blue values are exist into there. Firstly, we are calculate distance nearby. If there is not, then we will increase the distance area. Then again we will increase the distance area. So now KNN classifications. Obviously, if I'm talking about the classifications, also we have the two types of the data. First one is default and second one is blue. So it will calculate some new values come. So it will calculate the distance to all. Like KNN classification distance, like Euclidean distance. Now at the last, like what is the strength of KNN is very simple and intuitive, and it can be applied to data from any distribution. Obviously, when we have the distribution data, so many distributed data are there. So good classification, if the number of samples is large, obviously when we have the sample is large. So let's see the practical one by one. So firstly, I want to import the necessary libraries, like import, like I want to zoom little bit. So all the necessary library and also the seaborn. Once I have completed, I want to run this. Then I want to take the second. Then I want to load this data set for the KNN classifications. So how it is useful? So you can define the data like df. So firstly you have to upload this data here, which I want to load. So you can click to there and go back to there where is data set is there, gene expression. So I want to open this data set. It show the warning like once you have uh, closed this id, so your data will be removed. So you can save anywhere, like you can save into the cloud. So there are so many options are there, but this time I want to load this data like gene expression, like df. So this is the gene expression, and after that df dot head. So I want to show this data is successfully loaded or not. Yeah, fantastic. So I have successfully loaded this data gene expression.csv. I will also provide this data set into the chat box. So you can see I have successfully loaded the data firstly, and go back. Do not change this environment and simply click on this. So I'm focusing on the k nearest neighbor classifications. Now I want to discuss next. So we have the gene 1, gene 2, and like cancer present 1 and cancer present like no 0. So I want to visualize this data like SNS dot scatter plot like this one. So I want to change the column because we have the column name gene 1 and gene 2, and the hue that is I want to differentiate all the values according to this one, and the data. Once I want to click, so it will visualize this data. Like so, you can see there are gene 1 and gene 2. So number of values are same like 2 to 10, and the data is present in 1 and not this one. So these are the type of the genes. So the genes are presented. How many genes are presented? In this orange color, and not presented this one. So like the cancer. So when the cancers are there, so there the two classifications are there, and we can also classify this uh, chart into very effectiveness. Like for example, I want to visualize this scattered plot and this chart, and the alpha 2 is not requirement, but if you want to see, but I want to use the pltx lim 2 comma 6 basically, and plt ylim 2 again the 6. So and the plt dot show. So what is the use of this like 2626? So you can see this is classify all the data, but I want to hide because it is uh, remove the dimensionality. So now the data set is quite different, but the X lim is okay. The Y lim I want to increase the size, like 6 is not sufficient, so I want to change to the 10. You can see. So here all the data are overlap. Now you can see the data is uniquely visualized till to 6, and you can also take till to 10 and till to 6, and obviously to the same till to 10. Like the same, but I want to, like, so it will spread the data like till to 6, so it will, you can see that zoom out. So once I have visualized this data properly, then I want to split the data. Like I want to train and test this data. Like you can say train, test, split, and scaling data. So now I want to split the data. So we know very well with the help of Scikit-learn, one of the most famous library of the machine learning, like Scikit-learn or the Scikit-learn. Like from Scikit-learn, it is also the smart way and to work with that, like the model selections and the train test split. And now I want to use the standard scalar. Okay, learn pre-processing standard scalar. So now I want to use only two library which is most useful to split the data. So firstly I want to drop some values like cancer present, the axis. So the x, basically the df dot drop, so it will recommend me this one, like cancer present this data. So now in the y we have the same data like cancer present. So once I have dropped this data, so again I want to split the data, x train. So you can see the x train, x test, y train, y test with the help of this train test split functions, and I'm supplying here the x and y there, and the testing size we can use the 30%, normal 30, but random state it is not useful, we can take into the simple. So once I have successfully, but okay, we can also change the random step like 45, 42 as per the requirement. Once we have split the data, so now I want to apply the scalar, standard scalar, to isolate the value. And again, like scale extreme. So scalar.fit transform how we can fit the data, and how we can like transform this data. So I want to fit this data, training and the testing, and want to transform. So once I have successfully transformed this data, now I want to apply the most useful library like KNN, like from sklearn dot neighbor. Import k neighbor classifier. Once we have successfully defined, so I want to ready the model like KNN KNN model and K neighbor. So K neighbor classifier. So the neighbor I want to use 1. So again I want to execute. Once we have successfully classified the neighbor, then I want to fit into KNN model dot fit. Now training data and like scale training and normal white train data. So once I have successfully trained this data like the K neighbor classifier, now the main thing I want to understand and choose the K value. So understanding KNN and choosing K value. So now I want to apply the full test, and with the help of Panda, so I want to concatenate both the X test and the Y test of the data. So once I have concatenate all the data, then I want to find out the length. So you can see near about the length is there. And now I want to visualize again the data with the help of scattered plot. Now scattered plot the similar again, gene 1, gene 2, and the hue like the cancer, and present data is a full test. So that is the thing, and we depend on us right now I don't want to use this. I just visualize the simple data. Very good. Now you can see this data shape and the distance from all the data, and the data is very congested. So now after applying the scaling technique, so now the data is very clear. Now I want to evaluate this model. So how we can evaluate? Like model evaluate. So if I want to work with this model evaluation, so if there is any warning, so I want to import here like warnings, and I want to find out like the Y predictions. KNN model. So this is the normal warning, like if any warning will be shown, so I use in advance. So the prediction is successfully done. So now at the last, again I want to calculate. So the Scikit-learn matrix, this classifications and the confusion matrix. And after that, one more thing, I want to use the accuracy. Now I want to find out the accuracy of this model. So accuracy score, then I can pass the predictions value. Now the accuracy is 89, and you can say that the nearby 90. It is okay, very good, very nice. Now the confusion matrix. Similar, I want to pass this Y test and the Y predict. So it will show the accuracy of the like normal the confusion matrix, like show the data into the matrix format. Like you can see the data set available is starting this one. So now at the last, I want to print the classification, like classifications report to all of them. So you can see the accuracy of this one 89%, 89%. So this is normal way to find out the data and how to classify all the things. So now I want to visualize this data into the chart. So how we can find out the data, like so I want to use the elbow method. for choosing reasonable k value. So how we can check? So firstly, I want to type the code like test error rate. So suddenly I want to choose the value like not the 20, I think till to 30 I want to run this loop. And to work with the classifier k neighbor I and the KNN model. So now I want to fit this model like KNN, fit this scale value and also the predict I, the predictions. Okay, so I want to give some useful name like it is KNN model, like it is model for better class clarification. So we can say that it is model and like predict Y. So this is a more useful name. So KNN model. Now predictions Y. So you can see now I want to print the error rate, the test error accuracy. So the accuracy score, and then I want to print and I want to append all the error result. So once I have fetch out all the data into this algo, then I want to show this data into this algo like plt dot like a range from 1 to 30 test error rate and like color lines are there, marker are there, and we can also use the legends like plt dot title x label and plt dot legends. Now I want to ready and I want to visualize all this data. Now you can see very nice. So the error rate of k value, the value started from this one error rate in starting is high, then it will be down. So now once the error rate versus the k value, so the test error rate that is a blue and the line style is dash dash. So now I want to find out one more technique like cross validations. Like full cross validation search for k value. So now I want to define the like pipeline to work all these things. So firstly, I want to scale the data. So scale data. The second thing I want to discuss. So create model on scale data. Now after that, I want to discuss the step. So if I'm talking about in the steps, so again the first step basically the similar the data are split into training data and test data similar from the CSV file which we have loaded. So you can see I have defined these cross validations steps. So firstly I will scale the data, then I will create model and the scale data, then I will perform some steps. Let's see the scaler, standard scaler. And after applying this standard scaler, I want to apply the KNN classifier, like KNN, so K near classifier. So once I have applied this, so I want to get KNN dot keys. Uh, okay, so the params. So it will find out all the values like algorithm, leaf size, matrix. So these are the parameterized value of this algorithm. Now I want to apply operations on the data. Scalar scalar value to KNN, just the normally the KNN. So once the scalar value successfully defined, so again I want to use sklearn dot pipeline and import pipeline. So once I have import this sklearn functions, the pipeline, then again I can use pipe. So you can see I have successfully defined the grid search and the operations of this. Now I want to define some values like chosen. So now I want to define the k value and identify the k value and supply the range. So range 120, 130 we can use. So right now I'm just using the 120. And now I want to check out like how many k values are there. So there are the list of values. So now I want to apply the grid and the dictionary value. Basically we can give any name like KNN, similar to the neighbor name, then k value. So once I have successfully find out all the value into the grid, then I want to fully supply CV. You can give any name, classifier, and the grid search pipe parameter grid CV and scoring value. Once I have successfully tested this, so the final model basically the final model. So in the final model again I want to apply the grid recommended value like standard scalar, the k neighbor and again the same, but now the neighbor value I want to choose the 14 and 15 as per the requirement. And again the operation is scalar and the KNN, the name I want to use here, and the pipeline operations. So once I want to apply this, so again I want to fit the data in this pipe. Sorry, not the pip pipe, so pipe fit dot this data. So you can see the pipeline standard scalar and inside we have the k neighbor classifier. So once I apply this classifier, so you can use the data is fitted successfully. Now I want to prediction. Inside the predictions, I want to supply the pipe predictions and the pipe predictions the X test. And now the final thing I want to show the accuracy of this test, like classification report of Y test and the X test. Very nice. Now the accuracy is 94 and the above accuracy is 89. So after applying this elbow method, and to applying the scalar value again, so the accuracy is high. And now I want to discuss like the single sample, like single sample value, line of code. And after that, I want to predict the value. Now you can see the gene 1, gene 2, 6, and data type this one. And total is 194. And now I want to filter out again and predict the value. Then predict single sample and the values dot reshape. So once I have reshaped the data, okay, so I have mentioned the bracket here, so no need for the this square bracket. So the completely array value is 0. And the final accuracy predictions value, and you can say that the not the prediction probability. So now you can see the accuracy and the prediction value is show into this particular uh, array. So now it is all about this classifications tree, the k nearest neighbor, which I have discussed from the scratch. So firstly, I have defined what is k nearest neighbor, and I have loaded the data. So to visualize the data into the chart and to visualize the data into the scattered plot, training and testing the data, and to scale out the data, and again to reduce some dimensions and model evaluation. So after evaluation this model, to classify the data again and to find out the nearest neighbor and to find out some error. Now the error rate versus key value. Now full cross validation grid search for k value, this one. Now it is all about how we can fetch out the k values and the grid and the final model and the predictions for this value. So now in this session I discuss about the k nearest neighbor classification, so it is very helpful